Hello, everyone. Welcome to today's installment of Walter's Wonderful Words of Wisdom. We'll be going over two postulates of special relativity, presented by Walter Rodriguez, of course. Let's move on. Special relativity was first proposed by Einstein in 1905. It deals with objects and reference frames that may be moving close to the speed of light, but are not accelerating. Postulates. Okay, now, really this is just fancy talk for rules or assumptions. Now, these rules or assumptions are used to solve advanced mathematical or theoretical problems that otherwise could not be solved using common peasant logic, like when you don't know the answers to a series of questions on an exam. The rule states you should guess C on all of them, and you'd be wrong every time. You should guess B. Now let's break up each component of the two postulates of relativity. Now that we've broken them up, the first postulate of special relativity is, in simple terms, that the laws of physics shouldn't change, no matter what inertial frame of reference you're talking about. Your inertial frame of reference implies that in a given scenario, one point of reference is not moving, and the other point of reference is moving, but at a constant speed, meaning it has no acceleration. Now let's say you want to do an experiment to better understand the concept of relativity. You get in your car and you go 100 miles an hour. You drop a ball out the window and you see it go straight down, relative to you. Congratulations. You've just discovered a part of what the first postulate is trying to say. Now let's add your buddy as another point of reference. What does he see? He sees you about to be arrested for speeding and littering. It's all relative. The second postulate of special relativity. Now this is a little more complicated and is the result of lots of experiments that are beyond the scope of this lecture. The postulate states that the speed of light is constant in a vacuum, independent of the relative motion of the source. So let's take our flashlight G. I turn it on and light comes out of it. Now let's say this light goes at a speed of 1c, c being the speed of light. Just as a friendly reminder, it is 3 times 10 to the power of 8 meters per second. Now let's say I move this flashlight at 0.99c, meaning 99% of the speed of light. Again, that's in meters per second. And I ask you, what velocity does the light have? Now, if you said 1c plus 0.99c equals 1.99c, then you'd be correct. If the first postulate of special relativity didn't exist. It does, so you're wrong. It's still 1c. Now, what does this all mean? Well, consider the equation v times t equals distance. V meaning velocity and t meaning time when dealing with light. We know light is constant, so that means time and distance must change in the equation. This leads to time dilation and length contraction to make up for the fact that velocity must be kept as a constant. Now, time dilation and length contraction are pretty complicated. We will not be covering that in this lecture. For more information on this lecture, please review Dr. Delacourte's slides. Well, that's it, folks, for today's installment. Please remember to like and subscribe, and turn on notifications